साथियों नमस्कार। स्टैटिस्टिक्स के अंतर्गत आज हम देखेंगे टेस्ट ऑफ सिग्निफिकेंस। स्टूडेंट टी टेस्ट भी कहा जाता है। दिस टेस्ट इज mainly used for small population having sample size 30 or less and the population standard deviation is known. The t statistics is defined as t is equal to x bar minus mu upon s multiplied by root capital N. Here x bar is equal to mean of sample, mu is equal to actual means of the population, small is sample size and capital S is standard deviation. We know that standard deviation capital S is equal to root sigma in bracket x minus x bar का whole square upon capital N minus 1. Type unpaired t-test and paired t-test. Criteria for applying the t-test. Random samples are drawn from normal population. For testing the equality of the two population means the population variance are regarded as equal. The samples are less than 30. In case of two samples, some adjustment in degree of the freedom for the t are made. Unpaired t-test. The test is applied to unpaired data of independent observation made on individual of two different groups or sample drawn from two populations. Paired t-test. It is applied to paired data of independent observation from one sample only when each individual gives a pair of observations. To study the role of a factor or the cause when the observations are made before and after its play. To compare the effect of two drugs given to the same person. To compare the results of two different laboratory techniques. To compare observation made at two different sites in the same body. Confidence limit. Confidence limits are the lower and upper boundaries. Values of the confidence interval, that is the values which defines the range of a confidence interval. The upper and lower bounds of a 95% confidence interval are 95% confidence limit. This limit may be taken for other confidence level. For example, 90%, 99% and 99.9%. X bar plus minus capital S upon root capital N small t 0.05. Application of the t distribution. There are four applications of the t distribution. To test the significance of mean of a random sample, which is calculated by the formula t is equal to in bracket x bar minus mu bracket close upon capital S multiplied by root n. Second, the testing difference between the means of the two independent samples, and it can be calculated by the formula t is equal to x1 bar minus x2 bar upon capital S multiplied by root small n1 small n2 upon n1 plus n2, though both are small. Third, testing difference between means of the two dependent samples. Here, the testing difference can be calculated t is equal to d root capital N upon capital S. D means the mean of differences and S is the standard deviation of the differences. Fourth, the testing the significance of an observed correlation coefficient, and t is equal to calculated by t is equal to small r upon root 1 minus r square multiplied by root n minus 2. I repeat it. T is equal to r upon root 1 minus r ka square multiplied by under root n minus 2. Chi-square test. It is a statistical test involved the calculation of a quantity which is used to compare an observed ratio with an expected or theoretical ratio and to determine how closely the former fits the latter. The measure of chi-square enables us to find out degree of discrepancy between observed frequency and theoretical and expected frequencies, and thus to determine whether the discrepancy between observed and the theoretical frequency is due to the error of sampling or due to the chance. The chi-square is computed on the basis of frequency in the sample, and thus the value of the chi-square so the obtained is statistically. Chi-square is not a parametric test, but its value is not derived from the observation in a population. Hence, chi-square test is non-parametric test. Chi-square test for the single population of variance. Chi-square is equal to sigma in bracket small n minus 1 bracket close s square upon sigma square. Chi-square is standardized chi-square variable n sample size, s square is equal to sample variance, or sigma is population variance. Chi-square test for goodness of fit. Chi-square test for goodness of fit. The chi-square test is one of the simplest and most widely used non-parametric tests in statistical work. The quantity chi-square describes the magnitude of discrepancy between theory and observation, and it is defined as chi-square is equal to sigma in bracket observed minus expected bracket close का whole square upon expected. O is observed frequency and E is expected frequency. In case where expected frequency is not given, then E is equal to RT multiplied by CT upon capital N. E is equal to expected frequency, RT the row total for row containing the cell, and CT the column total for column containing the cell. RT the row total for the row containing the cell, and CT the column total for column containing the cell, and N is the total number of observation. Uses of chi-square. There are three uses of chi-square. Chi-square test as a test of independence. Chi-square test as a test of goodness of fit. Chi-square test as a test of homogeneity. Chi-square as a test for independence. By this we can find out whether two or more attributes are associated or not, and they are related or independent. Chi-square test as a test of goodness of fit because it enables us to ascertain how appropriately the theoretical distributions such as binomial, Bayesian, normal, etc. fit empirical distribution and those obtained from the sample data. Chi-square test as a test of homogeneity. By this, it can be determined whether two or more independent random samples are drawn from same population or from different population. Conditions for applying chi-square test. Capital N, the total frequency about be reasonably large, say greater than 50. No theoretical cell frequency should be less than 5. If it is less than 5, the frequency should be pooled together as in order to make it 5 or more than 5. Each of the observations which make up the sample for this test must be independent of each order. The chi-square test is wholly dependent on the degree of freedom. Z test. A Z test is used for testing the mean of a population versus a standard or comparing the means of the two populations. With large N is greater than 30 samples, whether you know the population standard deviation or not. It is also used for testing the proportion of some characteristic versus a standard proportion of comparing the proportion of two population. Example, comparing the average engineering salaries of men versus women. It is measured in terms of standard deviation and indices, how much an observation is bigger or smaller than mean in units, SD. So Z will be ratio of Z is equal to observation minus mean upon standard deviation is equal to x minus x bar upon SD. Z equal to x minus x bar upon SD. Z test. When Z test is applied to sampling variability, the differences observed between a sample estimate and that of population is expressed in terms of standard error instead of standard deviation. The score of the value of the ratio between the observed differences and SC is called Z. Condition for applying Z test. The sample size must be larger than 30. The sample must be random selected. The variance is assumed to follow normal distribution and data must be quantitative. Z test. The test of significance of difference between a sample mean mu and population mean x bar. Z is equal to population mean minus sample mean upon standard error in bracket x. Test of significance of difference between two sample means Z is equal to x1 bar minus x2 bar upon SC in bracket x1 minus x2 bracket close. F test. F test is named in honor of the great statistician R.A. Fisher. The object of F test is to find out whether the two independent estimates of population variance differ significantly or whether the two samples may be regarded as drawn from normal population having the same variance. For carrying out the test of significance, the F ratio can be calculated. F is equal to S1 square upon S2 का square, where S1 square is equal to sigma x1 minus x1 bar का whole square upon n1 minus 1 and S2 square is equal to sigma in bracket x2 minus x2 bar का whole square upon n2 minus 1. It should be noted that S1 square is always larger estimate of the variance, i.e. S1 का square is greater than S2 का square. Second, F is equal to V1 upon V2, where V1 is greater than V2. V1 is the variance of first observation, V2 is variance of second observation. The F's ratio can also be calculated by following formula. F is equal to S1 square upon sigma 1 square upon S2 square upon sigma 2 square. S1 square, where S1 standard deviation of sample drawn from population first, S2 standard deviation of sample drawn from population 2, sigma 1 standard deviation of population 1, sigma 2 standard deviation of population 2. The calculated value of F is compared with the table value of V1 and V2 at this 5% or 1% level of significance. If calculated value of F is greater than the table value, then the F ratio is considered significant and the null hypothesis is rejected. I repeat it once again. The calculated value of F is compared with the table value for V1 and V2 at 5% or 1% level of significance. If calculated value of F is greater than the table value, then the F ratio is considered significant and the null hypothesis is rejected. On the other hand, if the calculated value of F is less than the table value, the null hypothesis is accepted and it is inferred that both the samples have come from the population having the same variance. Since the F test is based on the ratio of two variants, it is also known as the variance ratio test. The ratio of two variants follows a distribution called the F distribution, named after the famous statistician R.A. Fisher. In n1 minus 1, the degree of freedom for the numerator, and n2 minus 1, the degree of freedom for the denominator. F table gives variance ratio value at different level of significance. df is equal to n1 minus 1 given horizontally, and degree of freedom df is equal to n2 minus 1 given vertically. Generally, sigma 1 square greater than sigma 2 square, but if sigma 2 square is greater than sigma 1 square, in some cases the two variances should be interchanged so that the value of f is always greater than 1. If the ratio value is smaller than the table value, the null hypothesis H0 is accepted, and it indicates that samples are drawn from the same population. If the calculated value is calculated value f, if the calculated f value is greater than the table value, the null hypothesis H0 is rejected, and conclude that standard deviation in the two populations are not equal. Assumptions in F test: normally the values in each group is normally distributed. Homogeneity: the variance within the each group should be equal for all groups. And third, the independence of error. The error variation of each value around its own group mean should be independent from each value. Thank you for watching this video. Have a good day.